Hi, folks. I just want to touch base a little bit about what it looks like to do sample calculations. And the sample calculations you would find on the tentative lab report, and it's down here on number 7, sample calculations. And if we take a closer look at that, it actually tells you the calculations have to include the slopes of tangent lines, a rate of acceleration, change in time, change in position, average velocity, time midpoint, and time squared. And where does that information come from? What does that look like? Well, when you do a scientific study, you have to tell people how you did calculations and have to include one calculation from your actual lab report. Well, for us to do slopes of tangent lines, we would simply say that we're trying to find slopes of tangent lines, which happen to be instantaneous velocities. We don't put the bar up there. And more specifically for us, I'm going to go ahead and use my fake wheel and axle data for our position versus time graph, and we're going to draw a tangent line at 3 seconds and then use the values that we picked up from the slope of the tangent line at 3 seconds. So when we do this, we just want to say what we're calculating, an instantaneous velocity, and this happens to be at 3 seconds. We would want the general equation, which is change in position divided by change in time. I'm going to use the expanded version of this, which would be position 2 minus position 1 divided by clock reading 2 minus clock reading 1. And I'd fill in the values that came right from this other document right here. So we've got on the top of the fraction up here, we've got 105 centimeters minus 45 centimeters divided by 5.2 seconds minus 3.1 seconds. And so the top of that ends up being 60 centimeters divided by 2.1 seconds. And that looks like that turned out to be 28.6 centimeters per second. And I'm going to go ahead and box that. So what did we say here? We said we were trying to calculate instantaneous velocities, which is what the slopes of the tangent lines give us. And we got one specific example. So that's just one slope. You don't have to do every single slope of tangent lines, just one example. The next one looks like it's rate of acceleration. Well, where did we do that? In the sample data, we did that on worksheets B and D. And here's my worksheet B. We made a velocity versus time graph, and if you look at the right side over here, we calculated the slope over here, which we eventually said was the rate of acceleration. So we could use those values for this. And so, like I did before, you want to start with what you're calculating, which is the rate of acceleration. How do we do that? We're going to use change in velocity divided by change in time. To take a look at that, we're going to look at velocity 2 minus velocity 1 divided by clock reading 2 minus clock reading 1. And I'm using the data from the slope of this graph over here. So that's the data points that I'm using from those slope points. And it looks like our second velocity was 40 centimeters per second minus 20 centimeters per second. And that's over 4 seconds minus 2 seconds. And so the top of that, the difference is 20 centimeters per second divided by 2 seconds, which equals 10 centimeters per second per second. And again, we've started with a general equation, expanded that equation, filled the original values in units, and then we've got an example of acceleration. What about the next four? Change in time, change in position, average velocity, and time midpoint. I remember running into those when we looked at that crazy data table. And so if we take a look at the crazy data table over here, we could look at the time frame from 2 to 3 seconds, which we'd say, so our change in time could literally be 3 seconds minus 2 seconds is 1 second. Our change of position could be 45 centimeters minus 20 centimeters, which is 25 centimeters. And I've got the formulas listed up here. T-mid, what time falls between 2 and 3 seconds? Well, it's 2 seconds plus 3 seconds is 5 seconds divided by 2. which is 2.5 seconds. And to find average velocity, we do change in position divided by change in time. That's this change in position divided by that change in time. So 25 centimeters divided by 1 second is 25 centimeters per second. So you, again, for each one of those, want to start with what you're calculating, like change in time, and then use the formulas. How do you do change in time? T2 minus T1, and so on. But you need a general equation, original values in units for each thing. And again, what are the other things we need to calculate? Change in position, average velocity. I should have run those together so much. Sorry about that. Oh. That's a mess. Anyway, I think you guys get the point at this point. So change in time, change in position. Looks like we have to do average velocity. What else is up there? T-mid. And then the last thing would have been time squared, which I believe are your 7. 1, 2, 3, 4, 5, 6, 7 slope calculations. No, or excuse me, sample calculations. And you just need one example of each on a single sheet of paper. But the values you pick, all of the work that you put in here have to be real calculations from your real WnX lab, not your worksheets. Thanks.